Hi everyone, in today's lesson we're going to talk about parent functions along with their transformations. So I'm going to give you the basic function of each one of these parent functions, and then we're eventually going to transform them. So the most basic linear function will be in the form y equals x, coming from y equals mx plus b, right? So if you wanted to write that out, you could just see y equals mx plus b. So basically, the most basic form of the line is with a slope of 1, so y equals 1, x, and a y-intercept of 0, right? My slope is my m, and my b is my y-intercept. So this y equals x is my most basic form with 1 being my slope and 0 being my y-intercept. So if we draw a picture of what this looks like, we can draw a nice xy axis, and then right through the origin, we're just going to draw a sketch of a line like such that has a slope of 1. Now, the most basic quadratic function is y equals x squared, and that comes from the most general form, y equals ax squared plus bx plus c. So to get this parent function of 1x squared, your a value would be 1 and b and c would be 0. So what does the most basic quadratic function look like? Draw an xy axis, put your vertex at the origin, and curve upward in both directions. That is the most basic quadratic function. Now our most basic cubic function is y equals x to the third. And what that graph looks like, draw another xy axis, put your vertex again at the origin, draw half of a happy parabola or a positive parabola, and then half of a reflection parabola, half of a sad parabola, and that is your cubic function. The most basic absolute value function is y equals the absolute value of x. And what that graph looks like is, again, draw another xy axis, draw your vertex at the origin, and your absolute value function looks like a V. So you want to draw a point at this origin. So it's different than our quadratic, whereas it's pointy here rather than curvy. All right. The most basic square root function is y equals the square root of x. And what that looks like is if you draw another xy axis and put your first dot at the origin, and you're just going to increase up slowly, and that is your square root function. Your cube root function is y equals, with a little 3, cube root of x. So if we draw our xy axis, put your vertex at the origin, and you're going to go kind of like a little bit of a square root this way, and then the reverse in the other direction. That is your cube root function. Then we have our exponential growth, exponential decay, and our logarithmic functions. So our exponential growth equation is y equals a times b to the x. Our exponential decay will have the same formula, except here the b will be greater than 1 for it to grow, and here the b will be between 0 and 1. And our basic logarithmic function is y equals log of x. So what these guys look like, let's draw a set of xy axis. So our exponential growth function will exponentially grow, never touching the x-axis. Our exponential decay problem will always start at the top and work their way down. And our logarithmic function will curve in this manner. All right, so it's important to know what these pictures look like because I'm going to ask you to transform them. So of these photos or of these graphs, I could ask you to say, take this absolute value function, shift it up, shift it down, shift it left, shift it right, and so on and so on. So it's important to know what each of these pictures look like so that we can transform them. All right, let's move on to the next page. So I'm going to describe each of the types of transformations. I'll give you an example and I'll give you the definition. So I'm going to give you the definition for any function f of x, okay? So if I want to do a vertical shift up or down, what we do is we take any function f of x and we add c on the outside. That will make us go up. And if we want to go down, we'll take any function and we'll subtract c on the outside, and we will go down c units. So what does it look like in as far as an example? Well, let's just say we took our quadratic function. We would say y equals x squared, that's my f of x, and then say plus 2. What you're doing here is you're shifting up 2 from our function f of x, which is x squared. Now this could change. Let's just say over here, I want to take my square root function. So y equals the square root of x, and I want to go down now. I could write minus 3, and that would be a shift down 3 with my parent function of my square root of x. So this piece here can change the x squared or the square root of x. It could be any function that you want to replace it with. That's why in the formula, I'm just writing f of x, meaning any function, okay? So let's go ahead now and keep going. If I want to do a horizontal shift, right versus left, the right shift is in formula form, is f of x minus c, and the left shift is f of x plus c. So what that would look like is we'd have to be, the c value would have to be inside the function or inside the parentheses. So a good example for this could be cubic. So let's just say we have y equals x minus 4 cubed. So because I have a cubic function, that's my parent function, and because I have a minus sign inside the parentheses, that means I'm going to go right. So this one means we are going to go right 4, and the parent function is cubic. Okay? If you wanted to write the functions here, the parent function here is the square root function, and the parent function here is the quadratic. Okay, so the next one, if I want to move left, I need to do f of x plus c. So let's use the absolute value function. So we've got y equals the absolute value of x plus 1. So what that means, because I'm inside the parentheses and I went plus, that means I'm going left. So I'm going to go left 1, and my parent function is the absolute value. Okay. The next shift will be a reflection, either over the x-axis or the y-axis. A reflection over the x-axis is when we put a negative in front of the function, and a reflection over the y-axis is when we put a negative inside the function. So we can use the x squared function again. I always like to use this one. So y equals negative x squared. You should remember that from algebra, right? If the negative is in front, then it's a sad parabola. So it would be a reflection over the x-axis, right? So that would be reflection over x. And the basic function is going to be quadratic. So a good other example, a reflection over the y-axis, is when the negative is on the inside. So with that one is, you could say y equals the cube root of negative x, and that is a reflection over the y-axis because the negative is on the inside, and the basic function is a cubic function. Okay. And then last but not least are our vertical compressions. These make your graphs narrower or wider. So we could have a number in front, c times f of x, and when c is greater than 1, we are narrower. If I have c times f of x, and I have c to be a number between 0 and 1, then we will be wider. So an example would be y equals 4x cubed. Because the number in front is larger than 1, our graph will become narrower, and the original function is cubic. And then we've got y equals 1/2. We could use x to the third again. The 1/2 is a number in front that's between 0 and 1. Therefore, our graph will be wider, and cubic will be our parent function. So when you come into class tomorrow, we're going to review all of these transformation rules, and I may put more of them together. I might do a vertical shift with a horizontal shift, or I might do a reflection and a vertical shift, or a vertical compression and a horizontal shift, or a mixture of all four. All right, so it's important that you know these rules now, so that way you're prepared for tomorrow in class. All right, that's it. Have a great night, everybody. See you tomorrow.